So for question 9.81, we're asked what these three has the strongest carbon-nitrogen bond, and which of these three has a lone pair, one lone pair electron. And so to figure out what has the strongest bond, we need to determine what's the bond order for each of these. And to just do that, we need to remember that bond order equals 1/2 the number of bonding electrons minus the non-bonding electrons. And then we're going to figure out how many electrons each of these have, and then we're going to place them using molecular orbital theory into the orbitals available. And we'll see, because we're working with carbon and nitrogen, our valence electrons come from our 2s and 2p orbital. So you'll notice we've got 2s, 2s star, 2p, 2 pi star, 2 pi star, and 2p star. So anytime we have a bonding orbital, we also have a corresponding non-bonding orbital of higher energy, and that's what these three 2s star, 2 pi star, and 2p star, that asterisk, that star, it simply means it's a non-bonding orbital. And then lastly, after we figure out how many electrons and how to place them, we're going to use, remember that this, as we work up, that's increasing in energy. And so we want to go from lowest energy orbital to highest energy orbital first. So how many electrons do we have to work with for the cation? Carbon would have 4 electrons, nitrogen would have 5 electrons, and because of the positive charge, we actually lose 1 electron for a total of 8 electrons. For the next molecule, we just have to look at the electrons from carbon and nitrogen for a total of 9 valence electrons we have to place. And then for the cyanide anion, we still have carbon with 4 electrons, nitrogen with 5 electrons, and because of the negative charge, we actually add in 1 more electron for a total of 10 electrons we have to place. And now all we have to do is look at how we place those electrons, and for our cation, we've got 8 electrons to place, so we're going to start at the lowest energy. Here's 1, 2, 3, 4, 5, 6, 7, and 8. Remember we need to make sure each orbital has 1 electron before we pair up. Now for the next molecule, we have 9 electrons. So we have 1, 2, 3, 4, 5, 6, 7, 8. And now, because we have 9, we can pair up those electrons in the 2 pi orbital. And for the cyanide anion, now we have 10 electrons we have to place, and so hopefully you can see the trend here, Here's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. And now to determine the bond order, all we need to do is 1/2 the bonding electrons minus non-bonding. So any electrons that are in a starred orbital, so this 2s star orbital, they are non-bonding electrons. And so that's all we have to do is what's the difference between our bonding electrons and our non-bonding electrons. So our bond order, 1/2 of, and so our bonding, we have 2, 3, 4, 5, 6 total bonding electrons minus just 2 non-bonding electrons for a total of 6 minus 2 is 4. Half of that, our bond order for the cation is 2. Our bond order for the next molecule, we've got 1, 2, 3, 4, 5, 6, 7 electrons that are bonding, so 7. And then again, only 2 non-bonding electrons. 7 minus 2 is 5, 1/2 of that, a bond order of 2.5. And then for the cyanide anion, we'd see we have 1, 2, 3, 4, 5, 6, 7, 8 bonding electrons, so 1/2 of 8. And then again, only 2, this 2s star, are our non-bonding electrons. 8 minus 2 is 4, and our 6, and half of that is 3. So we'll see for the cyanide anion, we have the highest bond order, so we'd have the strongest carbon-nitrogen bond as a result of that. So hopefully that helps answer this question 9.81.